So today what we're going to do is look at 4C. We're going to look at the general rule for finding the nth term of an arithmetic sequence. Now, when you're working with these, you're going to see some strange notation again. So we want to make sure that you understand where that notation is coming from and what's happening. So I don't expect you to derive this formula, but I do expect you to know how it was derived, where it came from. And we know this instinctively if you'll think about it. We call the first term, we give it a special name, we let it be A, right? And we know it's an arithmetic sequence if we have that common difference, which we call D. And to get the first term, we don't add anything to it, do we? So it's the first term, you add no D's, right? And the symbol for and the number for no D's is 0. So you're really adding 0 times D. To get the second term, we take the first term, and this time we do add the common difference. Okay? And if you have one of them, that means that you have a coefficient or a multiplier in front of it of 1, right? Because if you don't have a number in front, you always assume it to be a 1. If you have the third term, that's A plus a D plus another D, because every time you do a new term, you're adding another D to it to get the next term in the sequence, right? So that could be written as A plus 2 D's. And the pattern continues. If you want T to the fourth, it's A plus 3 D's. Good. All right? Now, so what's happening is that pattern is used to establish any sequence that it is an arithmetic sequence. And if that's the case, from that, we can derive a formula that will allow us to perform this operation for any term. So here's the formula. And again, you don't have to memorize it. It's on your formula sheet just exactly the way we're going to write it, but we can derive it. So if I want T to the n, so in other words, that's any term, right? If it's T to the third, the multiplier in front of the D was a 2. And 2 is 1 less than the 3. So what I do to get my multiplier is I can think of it another way. Instead of adding all those D's, I can simply take away from the term number I'm looking for. So we always still have to have the beginning. That's a given. But as a multiplier, if we simply take 1 away from whatever term number we're looking for, we can get the number that we need to multiply times our D. So the notation looks a little funny, but in reality, it makes perfect sense. Why? Right? And you're going to notice that about all formulas. They try to make it as simple as possible, but if you don't see where it comes from, sometimes they're just these vague, weird things that some mathematician has written out for you. But you can see where these things are coming from. So, for example, if I wanted the 10th term of a sequence, then that would be A plus 10 minus 1 times my D. So A plus 9D. Now, I don't know those numbers. I'm just using the general formula for it. But you'd be able to find any term by using that piece of that formula. And that's what we're going to look at in this section. All right. And because it's a formula, just like any other formula, like the simple interest formula or whatever, it can be rearranged depending on what you know. So if I know this term, then I can find A, but I would have to also know D. If I don't know 2 pieces, then that means I'm going to have 2 different equations that I need to solve at the same time. So simultaneous equations. So you're going to see some things here, some mathematics here that you might not have used in a bit, but it's a great review for some of the other things that you're going to be doing. So we'll look at some examples of each one. So it doesn't matter which one you know. If you know 1, you can find the other 2. If you know 2, then it's really easy to find the other 1, right? That's just a matter of substitution and simplifying. But if you have two variables, remember the only way that we know how to solve two variables is to create two different equations and then solve them at the same time. So we'll look at an example of that when we do these. Okay, there's your formula.